Number 1, you're supposed to write an inequality that describes its graph. You can see our boundary is y equals negative 2x minus 3. This boundary is dashed. Notice also that if you go from that boundary, if you go up, it's shaded. If you go down, it's not shaded. So as far as y is concerned, y is greater than, since it's above it. There's no equal sign since it's dashed. Negative 2x minus 3. Now there's a mistake here on number 2. This should say y equals 4, y equals 1. So the inequality for this, the top part is 4, the bottom is 1. Everything between is shaded. So when you write the inequality, write the smallest thing on the left. The smallest thing is 1, the lowest part in this case. The biggest thing on the right, that's the highest part, that's 4, and the variable between is y. We're saying y is bigger than 1, y is less than 4. If you look at this part right here, that's what this is saying. Y is less than 4. If you look at the graph, it's graphed below 4, that's less than. If you look at this part here, we're saying that it is above 1. Reading with the y first, y is above 1. Reading it with the 1, you're saying 1 is below y, 1 is less than y. Number 3, you can write this answer in a couple different ways. Looking at these boundaries, this one looks like it's solid, this one looks like it's dashed. So going from here down to here, we're between these two once again. What I would probably do is I would probably get y by itself. This is one way to do it. If I get y by itself here, we get this. So y is underneath of x plus 3. It's below it. So x plus 3 is the highest part. Y is less than x plus 3. But also looking here, y is above this curve of x minus 2. This one here is a solid boundary. So looking at these individually, like we did the other one, this here is referring to this part. Y is less than or equal to x plus 3. Looking at this part would be this part. Reading with the y first, y is greater than x minus 2. It's above it. Smallest thing on the left, biggest thing on the right, middlest thing in the middle. Number 4, graph each inequality or equation. This is in slope-intercept form. The y-intercept is negative 2. Slope is 3. So from that we go up 3 into the right 1. Connect those points with a line. Label the x-intercept. Define that, put 0 in for y. Solve the equation for x. X-intercept, y-intercept, graph. Number 5, y is not by itself. If we get it by itself, when I divide here by 2, you can do it in a couple different ways. The most effective way would be to divide each term by 2. That way you can leave your equation in slope-intercept form. Y-intercept is 5 over 2, so just go up wherever you want. This isn't labeled, and label that 5 halves. Slope is negative 1 over 2. You go down 1 to the right 2. Down 1 to the right 2. something like this. That point's probably, to put it more to scale, is probably more like so. But the x-intercept, which is what we need because we already have the y-intercept, x-intercept, also known as a root or a zero. 0 in for y. Get x by itself. Then multiply each term by 2, and then we get 0 is negative x plus 5. If I add x to both sides, I get x equals 5. Equal sign, so it's a solid line. Number 6, if I get y by itself, divide each term by 4. Put this in slope-intercept form and reduce my fractions. So x-intercept's at 1/2. Slope is 3/4. Up 3 into the right 4. Up 3 into the right 4. So I have a positive slope. Looks something like this. Find the x-intercept. Zero in for y and solve the equation for x. Then multiply each term here by 4. Get rid of my fractions. 3/4 times 4 is 3. Half times 4 is 2. Gives me negative 2/3. Is my x-intercept. Number 7 is different from the first 3 for 2 reasons. One, it's not in slope-intercept form, nor could it be written that way, because there's no y in the problem. And then 2, it's a less than symbol. If it's just an x and there's no y, it means that you're going to have a vertical line. So we go to 5. 1, 2, 3, 4, 5. Make a vertical line. It says x is less than, so it should be dashed. And then less than, where do your x's get smaller? To the left and to the right of 5. They get smaller on the left. Label the x-intercept. There is no y-intercept, but there is an x-intercept. Done. Number 8, I'm supposed to graph each inequality or equation, same directions. If I get y by itself here, by subtracting x from both sides, then multiplying both sides by -1. When you multiply both sides of an equation by a negative number, your inequality changes direction. Here my y-intercept is -5. My slope is 1. This is greater than, so it's dashed. X-intercept, 0 in. Put this in for the boundary. X-intercept of 5. It says y is greater than is above for the y values. So it should be shaded above. Number 9, y is not by itself. There's a negative here. If you multiply both sides by -1, once again your inequality sign changes direction. So this has a y-intercept of -1, a slope of -2. So I can go up 2 and to the left 1, or down 2 and to the right 1. So it puts us something like this. It says y is greater than, so it's dashed. X-intercept, put 0 in for y into the boundary. So I get an x-intercept of -1/2. Number 10 is a compound inequality. Nothing to be ashamed of here. Get y by itself like we did the other problems. We're going to subtract x from all three sides, the left, the middle, and the right. So it gives me -x minus 2 less than or equal to 2y less than or equal to a -x plus 4. Treat a compound inequality like you would an inequality. Instead of just doing it to two sides, you do it to all three parts, left, middle, and right. Then divide each term by 2, get -1/2x minus 1 less than or equal to y less than or equal to -1/2x plus 2. And you graph each of these separately. Each of these meaning you got this one here, and you have this one here. And you shade accordingly. Looking at the green one, we have a y-intercept of -1. We have a slope of -1/2, down 1 to the right 2. So it looks something like this. It's solid because it's an equal sign. Write that down here. This boundary is y equals -1/2x minus 1. X-intercept for this, put a 0 in for y into the boundary. An x-intercept of -2. The other part of the graph has an x-intercept of +2, a y-intercept +2. And its slope, same as this one, -1/2. It's going to be parallel to the other line. Its x-intercept, put a 0 in for y into the boundary. You're going to get an x-intercept of 4. This is getting kind of crammed in here. I'm going to pull this up a bit. Didn't mean to pull my lines away. Now if you look here, y is between those. It's bigger than this, but it's less than this, so it's everything shaded between. Number 11, it's absolute value. If we were to add 1 to both sides, you get the absolute value of x plus 3 plus 1 is less than y. Typically we like to read it with the y first, so it's saying y is greater than the absolute value of x plus 3 plus 1. This has a vertex of -3, +1. It goes to the left 3 and up 1. And it is the standard absolute value function. says y is greater than, so it is shaded above it. To find the y-intercept, as you can see here, there is no x-intercept. Put 0 in for x into the boundary. Simplify it so y is by itself. Get a y-intercept of 4. Now at this point you probably don't know how to graph this. I'm assuming we haven't talked about that yet. So it's very likely that if we haven't talked about absolute value functions, once you get y by itself, use your calculator to graph this. If that is the case, shortly we're going to learn how to graph this without a calculator. To find this point here using a calculator, use the second calc function once you have it graphed, and then ask it to find the minimum. Once you've done that, it's going to say left bound, put your cursor over here someplace, hit enter. Then it says right bound, put your cursor over here someplace, hit enter. And then it's going to say guess, hit enter, and it'll tell you that the minimum is -3, +1. Find the 0 of the function. Put 0 in for f of x, which is the same thing as y. Get x by itself. I subtract 6 from both sides. Keep in mind that this 0.5 is the same thing as 1/2. The opposite of times 1/2 is times 2. If I multiply both sides by 2, I get my 0 is -12. Number 13, do it very similar. Put 0 in for y. Get x by itself. When you put 0 in, you get 0 equals 19. That's a false statement. If you get a false statement, that means there is no 0. This here is a horizontal line. Horizontal line will not cross the x-axis unless it is the x-axis, but this isn't because it's 19. It's 19 above the x-axis. The average daily demand for the sale of soybean futures may be represented by a function known as the demand function. For example, in September of 1990, the average number of bushels demanded daily was 103.7 million. The function d of p equals 560 divided by p represents the demand for soybeans that particular month, where p is the price in dollars per bushel. A lot of information there. Some important things that I need to either write down or highlight. P is the price in dollars per bushel. D of P is the demand for soybeans for that particular month. What that means is demand. It means whatever price you set it at, the demand is how much you're going to sell. So let's say the price is $5 a bushel and D of P is 30 million. That means that you're selling it at the price, whatever I said it was, $5 a bushel, you're going to sell 30 million bushels. Keep in mind that D of P is measured in bushels. So this is in bushels. A, find the demand when the price is $6.15. It's so simple. Using a calculator, 560 divided by 6.15 is about 91.06. This is saying this is being measured in millions. So it's 91.06 million bushels. Interpret the meaning. Well, when soybeans are sold for $6.15 per bushel, consumers will purchase $91.06 million bushels. The equation y equals 0.82x plus 24, where x is bigger than 0, expresses the relationship between the nation's disposable income, x. So x is disposable income. In billions. In personal consumption expenditures, y is personal consumption expenditure in billions. Economists call this type of equation a consumption function. Graph the consumption function. Well, this should be pretty simple to graph. I have my x-intercept in here and my y-intercept. My y-intercept is 24. I'll just say that's right here. This y-axis is personal consumption in billions. So when x is 0, 24 is what y is. X-axis is disposable income. And then our graph has a slope of 0.82. That means it goes up 82 and to the right 100. I'm not going to go down here because then that's saying that my x value, disposable income, is negative. I don't know much about this stuff here, but I don't think that's possible. I'll assume it's not. So I think it should be more like array. So here's the graph. 2, name the y-intercept. Well, the y-intercept is $24 billion. Explain the significance of the y-intercept. I don't know what these terms mean, but I'm going to still explain what the significance is, because it's pretty simple. You're just basically stating what the numbers stand for. When 0 represents disposable income, when the disposable income is $0, the personal consumption expenditure is $24 billion. Hopefully you heard me, because that is ridiculous what I just wrote.